Rivers are dynamic, and nature makes frequent changes. Floods create new channels, and old ones become separated from the main flow of the river. It is in these side channels that many of our coho salmon are spawned and reared. This is also where many of our chum stocks find stable spawning gravel that helps to maintain their populations in flood-prone coastal rivers and streams. The river's natural meanderings across its floodplain continuously create and destroy this type of habitat. Fortunately, salmon are opportunists. They soon move into any good quality spawning or rearing area that presents itself. As part of the Special Projects Division team, the Small Projects Unit has worked since 1978 to expand the options available to those who are responsible for enhancing our salmonid resources. The unit's biological and engineering staff has developed an interesting array of low-maintenance enhancement techniques, particularly suitable for small-scale and remote enhancement opportunities. Side channels offer just such opportunities. Many of these channels act as flood pathways. Others have become totally inactive. Problems may arise when such channels are left in their natural state and used by spawning fish. One is unstable water flows. The river may flood and wash away eggs, alevin, or fry. Or it may not flow through a channel at all, leaving all or part of it dry for some of the year. The other problem is water quality. River flows can carry debris and large silt and sand loads. Both problems can be solved. Floods can be diverted by building a dike at the upstream end of the channel and along its side to divert floodwaters. Water supply is a different question. Water often flows underground, then wells up into these channels. This water is naturally filtered and can be warmer than the surface water in the river. Thus, a constant supply of water, in the form of upwelling groundwater, can be assured by excavating the channel, cutting it deeper to tap into the underground flow even at its lowest seasonal levels. One area where this semi-natural technology seemed suitable was on the Indian River, which empties into the head of Indian Arm. River instability, aggravated by man's industrial activities within the watershed, have upset the balance between the salmon and the habitats they rely on. This resulted in declining fish populations. The river, although near Greater Vancouver, is remote enough that a project which required minimal operation and maintenance was desirable. Small projects began to investigate, focusing their efforts on Jacks Slough, an existing side channel. The slough appeared to meet the criteria, so investigations at the site were undertaken. Standing pools of water were checked to find water table levels. Gravel on the site was examined for suitability. Timing is essential in building a groundwater channel. The work schedule should be arranged to minimize any harm to fish populations. Since various approvals are needed before work on a watercourse can begin, staff had to make the applications and obtain all permits in time to catch the optimum construction season. Each project site has its own design specifics. Such a project starts with clearing of the channel right-of-way. Suitable material from the excavation was used for dike construction. The first pass along the channel removes soils just down to the water table. This two-step excavation procedure minimizes siltation. Porous gravel encourages groundwater flow into the channel. Construction of the dike proceeds using gravel as it is excavated from the channel. As the channel approaches its final depth and cuts into the water table, groundwater begins flowing into it.
Good. Good.
A source of rock suitable for riprap was located nearby. The banks must be armored to protect them from being undermined by spawners digging redds. Special consideration is given to the aesthetics of these projects. It is hoped that after a few years, only a keen observer will notice that the channel has been improved. Its uniform depth and the well-armored sides will testify to human improvement. But the winding route, bank vegetation, and tree canopy will keep the project close to nature. This requires care in construction, leaving trees standing and undamaged, not leaving overburden in piles, and being sure that most evidence of construction is removed from the site. By September 1987, the job on Indian River was finished and the channel was ready for fish. They arrived on schedule and moved into the channels, utilizing the spawning area right to the top end. The first fish into the new channel were pink salmon, a species that seldom uses groundwater channels in southern BC. Nevertheless, a few did move into the newly improved side channel and spawn. A little later, the chum salmon appeared in strength. Both numerous and rambunctious, these fish prefer groundwater spawning areas above all, and usually dominate these habitats on the basis of sheer numbers. Towards the end of the chum run, the less numerous and secretive coho salmon slipped into the side channel. This species shows a strong preference for spawning in groundwater areas. The spawning adults were not the only coho in the side channel during the fall and winter. In far greater numbers than all of the spawners combined, coho fingerlings, the result of last season's spawning, lay quiet and unseen. An invisible migration had taken place into the channel during the early fall, and the fingerlings had pushed themselves deep into crevices along the banks. They came seeking a refuge, a quiet, stable place to winter. It's a scarce commodity in BC's turbulent and volatile coastal streams. The groundwater channel is virtually maintenance-free. The rock armor on the sides protects the banks from the erosion caused by spawners digging redds, although periodic inspection will be needed. If all goes according to the plan, the work at Jacks Slough will benefit the coho and chum salmon of the Indian River for decades to come. From past experience, we can estimate that the 2,200 square meters of Jacks Channel will produce over 1 million chum fry and 4,000 coho smolts each year. At many BC locations, groundwater side channels are being built to benefit local stocks of coho, chum, sockeye, and pink salmon. This technique has been shown to be a sound economic investment towards the rebuilding of our salmonid resource. While the full potential of this technique has yet to be realized, there seems to be no doubt of the bright future for work of this nature.